Hello and welcome to another exam paper walkthrough with myself, Mr. D. Today we're going to be going in a slightly different direction. We're going to be looking at a half paper. So this is a Edexcel GCSE half paper. They split a series of practice papers into halves, and this is the foundation version. We're going to be looking at practice set 1A, and we're going to be doing paper 2 today. So this will be a calculator paper. Attached to the description of this video is a link that will take you to a copy of the paper. I would strongly recommend you have an attempt at the paper before you watch the video, or do it alongside. Get some music on in the background. I've certainly got some on as I'm talking. And please subscribe if you like. Okay, so this should only take 45 minutes as it's a half paper, and we'll kick straight off. So question 1, write down the value of 9 in the number 213.95. So that 9 is going to be 9 tenths. So 0.9 or 9 tenths would be fine. So I'm going to go 9 tenths. I hope if I spelt it right. There we go. Okay, question 2. Work out 5.9 plus 3.17 squared. So I'm going to bring in my calculator here. So I'm using an emulator for the class whiz. If you've got a more modern calculator, that's absolutely fine. We'll talk about some of the functions later on. But straight away, say 5.9 plus 3.17 squared. Double check I've typed it incorrectly. 5.9, 1.17 squared, there we go, so equals, and we're looking at 15.9489. Okay, question 3. A petrol tank holds 48 litres of petrol when it is full. The scale shows information about how much petrol there is in the tank. Work out the number of litres of petrol in the tank. Well, from the diagram, if this is a half, this is obviously a quarter, so the petrol tank is a quarter full. So we want to work out a quarter of 48. That is, you could halve it and halve it again, so that could appear on a non-calculator paper. Or alternatively, you could type it in 1/4 times by 48. There we go. Question 4. Asif was asked to solve the equation 8x plus 1 is equal to 5. Here is his working, and we've got the working. Asif is wrong. What mistake did he make? So I tend to either work it out next to it, or I will kind of mark each line. So they've written the question down correctly, so I agree with that first step. I would then need to minus 1 from both sides. Which he's done correctly, so I agree with that step. He would then need to divide both sides by 8, which he has not done. So I'm going to circle the mistake. So, and then what mistake did he make on the third line? He should have done 4 divided by 8. Okay, so question 5. On the 1st of June, Brian has 312 in his bank account. On the 5th of June, he puts in 120. On the 10th of June, he puts in 25 into his bank account. This is how much Brian spends from his bank account from the 1st to the 15th. On the 16th of June, Brian wants to know how much money there is in his bank account. Work out how much money there is in his bank account. Okay, so basically we've got money put into versus money taken out. So if we start by looking at the total in his bank account, so let's just double check. So he started with £312. On the 5th he put in 120, and on the 10th he put in 25. So we want to work out, that will tell us how much goes into or should be in his account before we take into account the spending. So I'm going to do 312 plus 120 plus 25. So he has a total of 457, and from that figure, we want to take out all of his spends. So I'm gonna take a slight shortcut. I'm gonna just show that I'm going to be adding those together. So, and I'm going to make sure I type this in correctly. 42.4. I don't need the 0. Plus 21.05 plus 24.3 plus £64 and 20 pence plus £18 and 32 pence plus council tax £144.50 plus clothes of £84.20 plus £51 and 35 for supermarket spends. So let's double check I typed everything incorrectly there. That looks right, so let's just get the total for that. So as a decimal, we reckon that he would have spent £450 and 32 pence. So the amount in his bank account will be 557 minus 450.32. So I'm going to do, I've got this as my calculator answer at the moment. So if I do 457 minus that answer, that gives me, he should have £6.68 in his bank account. Right, I'll put that into my answer line, £6.68. Okay, question 6. Jim says, when you subtract a number from 10, the answer will always be less than 10. Is Jim correct? You must give a reason for your answer. For this, I would go, if you subtract a negative number, it will be greater than 10. And I'm going to put an example, e.g. 10 take away negative 2 would be equal to 12. Lucy says, when you halve a whole number that ends in 4, you will always get a number that ends in 2. Write down an example to show that Lucy's wrong. So Lucy would only be right if the tens unit is even. If the tens unit is, well, strictly speaking, that's not necessarily true. But an example would be if I did 14, so my tens unit is odd. So 14 divided by 2 would be equal to 7. And that's fine for my example. If you're looking at a 2-digit number, provided the tens value is even, then that will, provided the tens unit is an odd number, you'll always get a number that ends in a 7. Okay, question 7. Trina collects eggs from her hens. She labels the eggs small, medium or large. 20% of the eggs she collected in May were small. 24% of the eggs she collected in May were large. What percentage of the eggs she collected in May were medium? So to do this, I want to take the full amount, so that would be 100. And I want to take away the 2 percentages that we already know. And that will give me my answer. So I'm going to do 100 minus 20 plus 24. Again, this could be on a non-calc, but as it's a calc, we'll use the calc. So 56. Express 24% as a fraction, giving your fraction in its simplest form. So any percentages out of 100, and then we would, our next job is to simplify that fraction down. And again, on a calculator, our calculator can do the work for us. So 24 over 100 equals 6 over 25. Okay, Tina collects 75 eggs in May. Work out 20% of 75. So I'm going to do 75. So 20% is equal to 0.2 as a multiplier, or as a decimal. So 75 times by 0.2 will give you my answer. So that gives us 15. So 15. Okay, Sahar walked 7 kilometers from her home. She then had a rest. Sahar then walked home. Here is Sahar's travel graph. Distance from home on our y-axis and time of day on our x-axis. What time did Sahar leave home? Well, that's going to be this point here, halfway between 2 and 3 p.m. And because we're on a 12-hour clock, I would give my time as a 12-hour clock. So 2:30 p.m. Part B, how long did she rest for? Or how long did Sahar rest for? So we're going from there to there. So they've rested from 4 p.m. till 5 p.m. So that's going to be 5 minus 4, so 1 hour. What time did Sahar start to walk home? So she started to walk home at 5 p.m. And then work out the total time that she was away from home. So away from home, 2:30 to 7. So 7 p.m. minus 2:30 p.m. And again, don't really need a calculator for this, but just to show you time function on our calculator, really underused button. So 7 hours and 9 minutes. Take away 2 hours and 30 minutes. That gives us 4 hours and 30 minutes. So 4.5 hours. So we can actually even get that as a mixed fraction, 4.5 hours. Okay, question 9. A machine makes 36 trophies every hour. The machine makes trophies for 8.5 hours each day on 5 days of the week. The trophies are packed into boxes. Each box holds 8 trophies. How many boxes are needed for all the trophies made each week? Okay, so I'm going to do this in stages then. So 35 every hour. 36 every hour. So 36 times by 8.5 or 8.5. That's how many they would make a day. Times by 5, that's number of days. And then I want to divide that by the number in each box. So 8. So that will give me my total. And it will probably be a decimal. But we'll see. 36 times by 8.5 times by 5 divided by 8. So we get 191.25. So how many boxes are needed? Well, we've got enough for 191 and we've got some extra. So it would be 2 extra. So we'd actually need 192 boxes. Okay, question 10. Here is a 4-sided spinner. The spinner is biased. So that means bias means it is not even chance of landing on each one. Table shows the probability that the spinner will land on a 1 or a 3. The probability that the spinner lands on a 2 is the same as the probability that the spinner lands on 4. Work out the probability that it lands on 4. Okay, well, all of these would need to add up to 1. So what we would need to do is 1 minus, and then we would need to add these two together. The two known probabilities, 0.2 plus 0.1, and that will give us the probability that it lands on either a 2 or a 4. So we need to divide that by 2 to get our actual answer. And we could have done that as separate steps if we wanted to, but I'm going to do it as one step. So minus 0.2 plus 0.1, so that should be 0.7 anyway. Divide that by 2, give us 7 over 20 or 0.35. Okay, part B. Sonia is going to spin the spinner 200 times. Work out an estimate for the number of times the spinner will land on a 3. So the probability of it landing on a 3 is we do 300 times by the probability of it landing on 0.3, landing on 3, so times by 0.1. So that should be 30, sorry. Got my tens mixed up there. 30. And I've just spotted I misread that slightly. That's 200 times, so that should have been a 2 there. And that should be a 2 there, and a 2 there. And I should have typed into my calculator 200. Okay, question 11. ABC is a right angle triangle. AB is 6, AC is 9. Work out the length of BC. So we're using a bit of Pythagoras here. So if I call that missing length x for now, then by Pythagoras, x squared is going to be equal to 6 squared plus 9 squared. It's the hypotenuse, the longest side. So 6 squared plus 9 squared is equal to 117. So x is going to be the square root of that. So x is going to be equal to square root of the answer. So 3 root 13, which as a decimal is going to be 10.81665 ... to just imply that I haven't rounded. I've just written some of the answers. I want it to 3 significant figures. So first significant figure, second significant figure, third significant figure. So we're looking at 10.8. Question 12. Ali is planning a party. He wants to buy some cakes and some sausage rolls. The cakes are sold in boxes of 12. In boxes, there are 12 cakes in each box. Each box of cakes costs £2.50. The sausage rolls are sold in packs. There are 8 sausage rolls in each pack. Each pack of sausage rolls costs £1.20. Ali wants to buy more than 60 cakes and more than 60 sausage rolls. He wants to buy exactly the same number of cakes as sausage rolls. What is the least amount of money that Ali can pay? Okay, so I'm going to start by trying to find the lowest common multiple, or LCM, of 12 and 8. So on a calculator paper, the easiest way I think of doing this is if I simplify the fraction is equal to 2/3. So the lowest common multiple is going to be equal to 8 times 3 or 12 times 2. They both give you the same number. So the lowest common multiple is going to be 8 times 3, which is going to be 24. Right, so that's the lowest common multiple. However, that's not quite it. We want 60. So if we think about a 24 times table, we've got 24, then we'd have 48, and then we'd need to, that's still not enough, so we'd need 24 times by 3, which is 72, I believe. So 72, we're going to buy 72 packs of each. 72 is the number of each. So to buy 72 cakes, we would need to do 72 divided by 12. That will tell us the number of packets, and then times that by £2.50. And to that, we need to add the price for the sausage rolls. And again, that's going to be 24 divided by 8 times by £1.20. And again, you can do those sums separately. I'm going to do them with one though. So 72 divided by 12 times by £2.50 or 2.5, and to that I want to add on 24 over 8, and I want to times that by £1.20 or 1.2. So that takes me to £18.60. Okay, and I've just spotted a slight mistake in what I've typed into my calculator. Here, the numerator should have been 72. So if we go back and just change that to 72. If you're relying on your calculator, always best to double check what you've typed in, £25.80. So on my answer line, £25.80. Glad I spotted that. Okay, the nth term of the sequence is n squared plus 4. Alex says the nth term of the sequence is always a prime number when n is an odd number. Alex is wrong. Give an example to show that Alex is wrong. So as this is a foundation paper, I think probably the best process is to look at the first, let's say 4, 1, so let's say n is 1, 3, 5 and 7, so n squared plus 4 is going to be equal to, and I'm going to use the table function on my calculator because it's quite a useful one in this case. So the function I want to type in is n squared plus 4, so I'm going to type that in as alpha x rather than n squared plus 4. And I don't need a second function. I want my value to start at 1 and I want it to end at, I've done 7, but let's go a bit further. Let's go end at 13, going in steps of 2. So that will give me all of the values of n squared plus 4 for odd numbers all the way up to 13 as we're going in steps of 2. Right, so my numbers are so 5, 13, 29, 53. I'm going to go a bit further then, so let's go, these all look like prime numbers to me, so let's go 9 and 13 as well, 9 and 11 as well. So 9 is 85, which is definitely not a prime number. Give an example, so when n is equal to 9, n squared plus 4 would be equal to 85. There we go. And that brings us to the end of this paper. So I'm going to bring up, at the end of the mark scheme, we've got quite a nice table that I'll just share with you briefly. Okay, so this table gives you each of the questions. So we've got questions 1 to 13. It tells you which paper they've been taken from or whether they're new to the spec. It gives you the topics, which will also be in the chapter index for these. So if you struggled on particularly, let's say, question 4, solving linear equations, that's where you need to target your revision. It's also quite useful in this mean percentage of all. So the students that have sat this, the mean percentage of all, so they're saying that actually question 11 was the worst done. Out of the 3 marks, the average mark, well, only 33% got that correct. Which is quite useful if you particularly want to drill down into the statistics of that. And then that brings us to the end of the paper. Hopefully you found that useful. If you have, please drop any questions or comments into the chat for this, and subscribe if you like.